We have our first example for a second order differential equation and solving that second order differential equation using the Laplace transform. I have the two formulas for the Laplace transform of the first derivative and likewise the second derivative. Now I'm going to input my initial conditions just off the fly. I'm going to say x of 0 is equal to 1 and x dash of 0 is equal to 0. Just to simplify the calculations a little bit, but not too much. Anyway, I haven't done this problem, I've made it up. Simply just made it up on the fly. So let's see how we go. Let's see what the solution's like. So the first step is to just take the Laplace transform of both sides. So d squared x dt squared minus dx dt plus 2x is equal to the Laplace transform of e to the minus t. Now, we input what those answers will be. So, applying the formula seen above, we can say that this will be s squared xs minus s x of 0 minus x dash of 0, well, I know that's going to be 0, minus the Laplace transform of the first derivative, which is just going to be sxs minus x of 0 plus 2xs is equal to 1 over s plus 1. Alright, that was a mouthful. Alright, we're chugging along. Let's keep going. So, I am going to automatically factor out xs, because that's the whole point. The whole point is you take the Laplace transform, you do a lot of algebra, and then you isolate xs, you take the inverse Laplace, and that's your answer. So, s squared minus s plus 2. And, sorry, before I do the equals to, I'm going to say that's minus x is 0. X is 0 was 1, so that's minus s. And then I have another x of 0 here, so that's minus 1. And that's it. And that's just equal to 1 over s plus 1. So let's keep going. So xs, s squared minus s plus 2 is equal to 1 over s plus 1 plus s plus 1. So what you do here is you play around with the right hand side for a little bit, because the idea is you want to leave this side alone until you've got this all onto one common denominator, because then the partial fractions computation is simply just, you only have to do that once. Otherwise you have to do it multiple times. So 1 plus s plus 1 plus s plus 1 over s plus 1. So let's keep going. So xs s squared minus 2 s plus 2. I'm sorry about that. So 1 plus s squared plus s plus 1 over s plus 1. So we're getting towards the end of the video and the end of the page. xs s squared minus s plus 2. As you can see, this is just invigorating to do. So I'm going to put the s squared term here. So I have an s and I have an s, that's 2s. And then I have a 1 and 1, that's plus 2 over s plus 1. So then finally, our final, and we're ready to solve the inverse Laplace of s squared plus 2s plus 2 over s plus 1 multiplied by s squared minus s plus 2. Alright, that's for the next video. And then after that, we're bada bing, bada done. Alright, I don't know if I should have done that. Maybe people are going to unsubscribe and I'll have like 0 subscribers. Anyway, see ya.